All right, so here's a final video for today. I'm just going to go over your assignment that you're going to be working on for the rest of the period for today. So you picked this paper up as you walked in through the door. This is 9.2.1 Inheritance, task card 1, looking at karyotype analysis. So if you weren't here last week, as far as when I went over what a karyotype is, I'll just pull this up real quick for you. Karyotype is this right here, what we're looking at. Okay, so here's a human karyotype. It's simply a map of your chromosomes, is what it is. So on the left here, we see a map of a male's chromosomes, and we know that by looking at their 23rd pair of chromosomes there, right, called the sex chromosomes. You have a X and you have a Y chromosome. So this indicates that we're looking at a male chromosomes. Remember, chromosome pairs 1 through 22 are called autosomal chromosomes, and of course your 23rd pair are your sex chromosomes. In this part here, hold on. Oh, I didn't mean to do that. On the last, let me pull this up, hold on real quick. All right, here we go. So here on the right side, we're looking at female's chromosomes, right? And we know that because at the end, her 23rd pair is XX, all right? And that's indicated there. So this is a karyotype. It's a map of your chromosomes. All right, so with that in mind, let's go back to your assignment that you have today. Make sure you read the part that says read this, of course, right here. Okay, read that part. And let's look at the task that you have to do today. So the task part says this: 4 pregnant couples come to you and ask you to perform a genetic analysis on their baby. So you're kind of playing a genetic counselor. That's the role that you're playing right now, all right? It says to create, analyze, and compare karyotypes for the 4 different fetuses. So in this packet that you have, if you open it up, you have 4 different karyotypes for 4 different fetuses. Okay, so attached to this sheet. That's one of the materials that is provided for you. All right, and then there's also scissors. So just come up to the front if they're not on your tables yet already, and you can open up the boxes or the boxes with the markers and color pencils and so forth, and there's scissors in there as well. So you've picked up this packet and a blank sheet of paper that you're going to paste this on. You'll cut it and paste it on there. All right, so you're going to create karyotype. You're actually going to create you're actually going to create 4 karyotypes. All right, so you'll need 4 blank sheets of paper, or you could just use 2. That's fine. You can use 2 blank sheets of paper and put one karyotype on one side of the paper and the other karyotype on one side of on the other side of the paper to save some paper for all the classes. All right, so the task hints are here. It says humans have 23 pairs of chromosomes. Pairs 1 through 22 are called autosomal chromosomes, which we've talked about already. In autosomal chromosomes, the largest and the longest chromosome is pair 1. So we call that chromosome 1. These are the longest and the largest. So there's an image right here off to the side, okay, of a larger looking chromosome. Chromosome pair 22 are the smallest and shortest chromosomes. So there you go. You have chromosome pair 22. Okay, so if you compare them in size, one's larger than the other. And of course, our 23rd pair, our sex chromosomes, are identified by X and Y. Females, of course, are XX, and males are XY. So this is what they look like here, all right? So chromosome pairs are known as homologous chromosomes, okay, where one is inherited from mom and the other one's inherited from dad. Homologous chromosomes can be identified because they have the same length and banding pattern. So read that again. Homologous chromosomes can be identified. In other words, that the pair can be identified because they have the same length. They're the same length. Okay, well, I should go up here. They're the same length. All right. And they have the same banding pattern. So the bands that come across the chromosomes, the banding pattern, they are exactly the same. Okay, if they're a pair. One of the patient's fetal karyotypes, so one of the 4, shows no genetic abnormalities. Well, maybe it's a happy baby, but it's a healthy baby, all right? And so you'll also determine the sex of that baby as well, all right? So here's your task criteria. Identify the sex of the fetus. So you're going to do that um, for all four of the fetuses, and identify and interpret potential impact of any genetic abnormalities. And I'll explain that in a moment, all right? So that's your task criteria there. What you're going to do is you're going to use this. The appendix is the next page. So you can flip to this page. You're going to use this as a way to identify the chromosomes, all right? So this is kind of like a key for you to use. Chromosome pair 1 should look like this. It should be similar in length, and it should have similar banding patterns to this, all right? Chromosome 2 would look something like this, 3, and so forth, all right? So here's a way to classify the different chromosomes, okay? And of course, you have your XY, your male set of chromosomes, and XX, your female set of chromosomes. So if you notice here, there's a line that goes across these chromosomes, okay? That line is going across the centromere, right? The center of each sister chromatid. So kind of going back to reference of what we talked about last semester, this line here goes across the centromere, okay? And we actually call these based off of where this line goes across. So if you notice, if this is the middle, if this is the center, the centromere of the chromosome, one side is shorter than the other side of the sister chromatid. All right, so looking here, chromosomes are arranged into 7 groups based on size, the location of the centromere, and the banding pattern, all right? Centromeres can be found in the middle of a chromosome. So if you look at chromosome pair 20, the centromere is found in the middle here, so we say that is metacentric, meta for middle, metacentric. If it's closer to one end than the other, so if we look at pair 10 up here, the centromere is closer to this end of the sister chromatid versus this end, right? We say that it is submetacentric, right? Submetacentric. And if it's very close to one end, so for example, we would say that the centromere is acrocentric here. It's closer to one end, so it's acrocentric. And in this case here, this would be submetacentric. Okay, submetacentric. All right. So you can use that to help you identify. Here's the different groups. Group A, these are chromosomes 1 through 3. So this is how we group them. Group A, chromosomes 1 to 3, groups 1 to 3 are largest with metacentric centromere. So this is kind of like the definition. This will help you identify chromosomes pairs 1 through 3, and we call that group A. And so if you kind of go through this, you're going to use this as a key. Group B, chromosomes 4 through 5 are large with submetacentric centromeres, all right? And so forth. So this key right here is going to help you identify and figure out what is chromosome pair 1, what is chromosome pair 2, and so forth, all right? Even all the way to being able to identify the pair of X and Y chromosomes, all right? So this is a key for you to use. So you're going to reference this page, okay? So moving on, here we go. This is patient 1, here's karyotype number 1. So what you're going to do is you're going to create a map, a karyotype for each fetus, all right? So let's talk about this one here. So what you're going to do here is you're going to cut each individual chromosome out, so you'll cut all the way around it. It doesn't have to be perfect. You're going to cut each one out, all right? Cut each one out and identify out of this karyotype for this fetus, what is autosomal chromosome 1, okay? And on that separate sheet of paper, the blank sheet of computer paper, you're going to paste it. That'll be your first one. You're going to paste it on that paper. That'll be autosomal chromosome 1, okay? So how do you, by looking at all these chromosomes, how do you figure out what is autosomal chromosome 1? Well, that's when you go back and you reference this page. All right, if we're talking about autosomal chromosome 1, it's part of group A there. It's a large chromosome. It's one of the largest ones. And the centromere is metacentric, meaning it's in the middle of a chromosome. So you can use this to help you identify it. So using that as a reference, you go back And maybe by looking at all these chromosomes here, these two right here look like a pair. Okay, remember you're getting one set of chromosomes from mom and one set of chromosomes from dad, right? So if you go here, you try to figure it out. The banding pattern of these two, just looking at these two right here, look exactly the same. And the centromere is metacentric. It's right in the middle. Okay, it's right in the middle here. All right, banding pattern's exactly the same. They look like they're the same length. So these are probably, if I continue looking, to me, I would say these are autosomal chromosomes 1. So I would cut these out, both of them out individually. Okay, remember the whole thing. So all of this you're cutting out. And you would paste this onto the paper. Remember, you're making a karyotype that looks something like that right there. So you would paste it on the paper, all right, and you would label it 1. Those are autosomal chromosomes pair 1. All right, and you're going to do that for each one all the way to autosomal chromosome 22, and then figure out if you can identify the sex for this fetus. So by looking at this, see if you can identify, is this a male or is this a female? And then you'll cut those out and paste those sex chromosomes and identify the sex of that child. All right, so you can do that for each one. So this would be on one sheet. Make sure you label it. So you label this, you can label this patient 1, okay, or you can label it karyotype 1. On the flip side of that paper, on the computer paper, you can do karyotype 2. All right, go through it, do the same thing. You'll glue it down, cut them out, glue them down. And then on a second sheet of paper, you can go karyotype 3. And on the flip side of that, karyotype 4. All right, so that's your task for today. It probably will take the rest of the period to work on it. And remember, your task criteria is to identify the sex of the fetus and identify and interpret potential impact of any genetic abnormalities. This part right here we'll do on Monday, all right? And so hopefully we'll make sense of this on Monday, all right? So hopefully this helps, and I will see you all on Monday. All right, see you then.